All right, we are starting to review for our test. Our test will be on Thursday this week. The first learning target says I can simplify expressions with rational exponents. When we have a fraction power, what does the top number represent? Top number is the power, and the denominator is the root. Okay, so we have 27x to the 5th y to the 8th divided by 125x squared y squared, and then we are raising it to a 1/3, which means we are doing what? We're cube rooting it. Is there anything inside that we can clean up first? Yes. Then do that. All right, can we clean up 27 and 125? Any common factors that we can take out? Okay. We'll leave those. The x's, though, we had 5 on top and 2 on the bottom. If we take 2 off of each, we are left with 3 on top. Okay, and for the y's, we had 8 on top and 2 on the bottom. Again, getting rid of 2 from each, we'd have 6 left on top. We can then cube root this. Yes? What's the cube root of 27? What's the cube root of 125? Okay? The cube root of x cubed. X, and the cube root of y to the 6th, y squared. Notice it says assume all variables are positive, so we aren't worrying about the absolute value piece that we had in the first half of the chapter. Okay? The second one says we are taking negative 27 to a negative 4/3 power. What happens with the negative power? It has to flip it. Okay, so let's go ahead and flip this over. We're going to have 1 over negative 27. Now we are raising it to a 4/3 power. Okay? The 4 means I have to raise this to the 4th power. I don't know what 27 to the 4th is, so I'm going to go ahead and do the cube root part first. Okay? The cube root of negative 27 would be, all right, so this becomes 1 over negative 3. Now we can raise that to the 4th power, and we end up with 1 over 81. Okay? All right, third one. We have a to the 1/3 and a to the 2/5. What do we have to do when we want to combine those a's? We need a common denominator. Yep. So what would we use for denominator? 15. Okay. So we're going to have a to the what? 1/3 would be the same as 5/15. And then we have a to the 6/15. So we end up with a to the 11/15. Okay. Question 4. We have 9x to the negative 4, y to the 6th, and we're raising the whole thing to a negative 1/2. Again, let's deal with the negative. It's going to do what? It's going to flip stuff. Okay, now the 1/2 is going to do what? Square root it. Okay, so the 9 is going to get flipped over. Okay, the x to the negative 4 is going to get flipped over, but then because it's still negative, we have to flip it back. Does that make sense? 2 negatives are going to cancel that out. Okay, the y to the 6th, we would flip it over. And now we can raise everything to a 1/2 power, which is really just square rooting. Okay? So what is the square root of x to the 4th? Okay? Square root of 9. And y to the 6th would be y to the 3rd. Okay? Again, there's different routes you can take. If you want to distribute that power, you certainly can do it that way too. All right, and then simplify it. You should end up with the same answer. Okay. Our next one. It says to simplify, you have the square root of 2 over the 5th root of 2. We can't simplify them with the way they're written right now. They're different types of roots. But can we rewrite that with exponential powers? Or sorry, with rational powers, fractions. The square root of 2 would be 2 to the 1/2. And the 5th root of 2 would be 2 to the 1/5. And once we get it into that rational exponent piece, we can do what? We can get a common denominator. The bases are the same, right? They're both 2's. So we want to be able to put this together, simplify it. But written with the radical notation, we can't. Written in rational exponent notation, we can. Okay? What common denominator would we use? Okay, so we'd have 2 to the 5/10 over 2 to the 2/10. So simplifying, we would have 2 to the 3/10. Okay? Now, typically, if the question was given to you in this notation, we want to give our answer in that notation. Okay? So if we have 2 to the 3/10, can we do 2 cubed? We know that 2 cubed is 8. Is 8 one of our perfect powers of 10? Or base to a 10th power? So we can't break it down there, but we can say it's the 10th root of 2 cubed, which would be the 10th root of 8. Okay? So again, if it's given to you in that radical notation, you should give your answer in radical notation. Okay? Question 6. We have x to the 2nd over x to the -4th, and the whole thing is raised to a 2/3 power. Can we clean up inside? Yes. That x to the -4th, we want to think of bringing that up, right? Flipping it so it's not negative anymore, which means the inside simplifies to what? X to the 6th. We are then raising it to a 2/3. What do you do when you have a power to a power? We multiply them. What do we get if we take 6 times 2/3? 12/3 is 4. So this reduces down to just x to the 4th. Questions on that first page? All right. Our second learning target says I can solve square root equations and equations that have rational exponents. We have 4 examples of this. How do we undo when we have a square root? We have to square both sides. All right. If we square both sides, on the left, the square will cancel the square root. We just get x plus 14. What do we end up with on the right-hand side? This is a common mistake students make. They square the x, they square the 2. You are really squaring this quantity, right? So think of foiling it out. What do we get? Okay. Now, we have a quadratic equation. We have an x squared in there. How do we solve those? Okay, we can get one side equal to 0, and then we would do what? Factor it. Yep. All right, so let's subtract the x over. Let's subtract the 14 over. We end up with 0 now on the left. On the right-hand side, we have x squared plus 3x minus 10. Is that factorable? What do we get to multiply to be -10 and add up to 3? Okay. So our solutions would be x being -5 or x being a 2. Are we done with this question? We have to check them, right? Because we can have extraneous solutions. It specifically says check for those. So we are going to plug this back into the original question. All right, so original question is the square root of x plus 14 equaling x plus 2. If I dump a -5 in here, -5 plus 14 is 9. Square root of 9 is 3. On the other side, if I put a -5, add 2, I get -3. Are those equal? Since they are not equal, this is extraneous. Okay, doesn't work. Checking the 2. Again, dumping it back into both parts. 2 plus 14 would be 16. The square root of 16 is 4. One side is 4. On the other side, we put a 2 in there. 2 plus 2. That one does work. Okay, so this would be my answer, and it's the only answer for that question. Okay, I'm going to pause the recording. I want you guys to try the next 3. All right, question 8. We are raising this left side to a 1/2 power, which is the same as this, correct? Mean the same thing. How do we undo the square roots? Square both sides again. We end up with 2x minus 5 equals 9. Adding the 5 over, 2x would equal 14, so you got x equaling 7. Did it work? We dump it back in. We have the square root of 2 times 7 minus 5, and it's supposed to equal 3. We've got 14 minus 5, that's 9. Square root of 9 is 3. Okay? This one, we are cube rooting it. Cube rooting 3x minus 1, and it's supposed to equal a 2. We undo a cube root by cubing both sides. 2 cubed is 8. So we have 3x minus 1 equaling 8. Adding our 1 over and dividing. And then we check it. 3 times 3 is 9. 9 minus 1 is 8. The cube root of 8 equals 2. And that works. Okay? What did you try on number 10? This one's a little more complicated. Good. Divide out the 2 first. So we now have x minus 1 to the 2/3 equals 81. How do we undo a 2/3 power? Yes, raise it to a reciprocal power. So I'm going to raise both sides to a 3/2. What is 81 to the 3/2? Take it in pieces. The square root, right? The 2 on the bottom means we're square rooting. Okay? The square root of 81 is 9, and 9 cubed is? Okay. Is that my only option? Remember when we talked about this? If you are square rooting something, right? If you add a square root symbol, which we did here, even though we put it as a fraction exponent, we really did insert a square root symbol in there. You have to consider both the positive and negative roots. So we really are taking positive and negative 9 and cubing it, and we're going to get positive and negative 729. So you should have x minus 1 equals plus and minus 729. If you forgot the plus minus, make a little note in your notebook there, so you study that one. Adding a 1 to the other side. Adding 1 to a positive 729 gets me 730. Adding a 1 to a negative 729 gets me negative 728. Okay? Checking them. Sorry, back in the original. All right, so 730 minus 1 is 729. Its cube root is 9. 9 squared is 81. 81 times the 2 is 162. Okay? Checking our negative 728. Subtracting 1 gets me negative 729. I have to cube root that, which is negative 9. Then I have to square that. I get 81. Timesing by 2, I'm back to the 162. So they do both work. Okay? All right. We are going to jump to the last page of your review. We're going to look at section 6.8. This was the graphing stuff. Okay? So when we are graphing square roots, what are the x values that we want to pick? Good, 0, 1, 4, 9. And we pick those because they're easy to square root. Yes? When we are cube rooting, what are my easy numbers to pick? 0, 1, and 8 are perfect cubes. But remember, with cube roots, we have the whole graph, right? The whole twist. So we have to have some negatives in there as well. So we also want to use -1 and -8. Okay? We are going to graph the parent function first. The parent function is just our basic square root of x or our basic cube root of x. Okay? We are going to then analyze the transformations and figure out where this graph moves to. And then it says to find the domain and range of the transformed function, not the original one, but the one we've moved. Okay, I'm going to give you guys a couple minutes. Go ahead and try these. All right, so square rooting 0, we get 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. That's my parent function. Yes? What have we done to this parent function? What kind of transformations? Okay, so that negative sign there is a reflection over the x-axis. Okay, what does this 2 do? Okay, right 2 and up 3. So once we know our points, we should be able to do those transformations. So 0, 0, 1, 1, 4, 2, and 9, 3 are the original parent function ones. Okay, and I would expect to see that shown on your graph. Okay, it says graph the parent function. Then we're going to transform it. So we want to reflect over the x-axis. Reflecting the origin isn't going to move it, but then we want to go right 2 and up 3. And since that is the end point of my graph, I'm going to make it a little bigger so I remind myself of that. Okay, the point 1, 1, I reflected over the x-axis and move it right 3 and up 2. Sorry, right 2 and up 3. The point 4, 2, reflecting over the x-axis puts me at 4, -2. I'm going to go right 2 and up 3. The point 9, 3, reflected over, puts me down there. Then I need to go right 2 and up 3. I end up there. So my graph should look like this, with an arrow going off to the right. Okay, it's a square root graph. It's been reflected upside down and then shifted right and up. Now, based on that green graph, what is the domain? What do we know about our x's? Greater than or equal to 2. And my y values are less than or equal to 3. Yes? 3 is the highest y value I use. All right. And we described the shift up there already. Okay. For the cube root, when I cube root -8, I get -2. -1 is still -1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. So we have 8, 2. We have 1, 1. 0, 0. -1, -1, and -8, -2. We have that twist. Yes? All right. What kind of transformations have we done to this one? Left 1 and down 2. Okay. So can I take all of those dots and move them left 1 and down 2? So I still have that same kind of twist. It's just down a little bit. Okay. Domain and range for this one. For both? All reals? Okay. All right. Any questions on the graphing part? All right. The last question here says, rewrite the function to make it easy to graph using transformations. What's our goal here? What are we trying to get it to be? We have a square root of x minus h plus k. That's kind of a generic transformation format. What's wrong with it is there's this 4 here, right? When we do transformations, we don't want a coefficient in front of our x. So step 1 is going to be still inside that square root, but we're going to factor the 4 away from the x. All right, if we divide a 4 out, we have a single x and a plus 5. We still have the negative 7 out on the outside. Okay, so now it's closer. What can we do with this 4? Yeah, so what we're really doing is this, right? We're splitting that apart. We can do that because it's multiplication. We can square root the 2 factors separate. So the square root of 4 becomes 2. Then we have the square root of x plus 5 and the minus 7 on the end. So what transformations are we doing to this? Okay, this is a vertical stretch by a factor of 2, which means all my y values would get doubled, right? Make them twice as high. What is the 5 going to do? Left 5 and down 7. Okay? All right. For your homework today and classwork, you are going to do the 2 formative quizzes. There's one on 6.6, there's one on 6.7. I will get those open for you in a minute. I'm also going to give you a review packet. And you guys are going to do questions 1 through 19.